Hello friends, myself Rajendra Mahajan presenting my video on matrices point solution of linear simultaneous equation non-homogeneous type. Let us solve the problem, test for consistency and hence solve. Equations are 4x minus 2y plus 6z is equals to 8. Second equation is x plus y minus 3z is equals to minus 1. And third, 15x minus 3y plus 9z is equals to 21. Why it is called as non-homogeneous? As the values on the right hand side of the equation are not equals to 0. If anyone is non-zero, then that system is said to be a non-homogeneous type. Here it is non-homogeneous type. Then to solve it, we have to take a combination of matrix A and matrix D. A is the coefficient of these equations or unknowns. Therefore, first equation we have 4 minus 2 6 and is equals to 8. Second equation coefficients are 1 1 minus 3 and minus 1. Then from third equation 15 minus 3 minus 9 and 21. Then we have to convert this augmented matrix to its canonical form by applying elementary row transformation. What do you mean by canonical form? Already I explained in my previous two examples. Canonical form means we have to convert that principal diagonal elements, means diagonal from left to right, to non-zero, and lower diagonal elements to 0 by applying elementary row transformation. Therefore, the leftmost element is here 4. We interchange this first and second row so that we get 1, and using that 1, it's very easy to convert the remaining elements to 0 in that first column. 1, 1, minus 3 and minus 1. And second row 4 minus 2 6 8. Third row as it is, no change. 15 minus 3 9 and 21. For better understanding of the problem, please watch the video up to end. Using that one, we convert that 4 to 0, and this third row elements are multiple of 3, or multiply that row by 1 by 3. We get first row no change, 1 1 minus 3 and minus 1. Second row, applying this transformation, r2 minus 4 r1, 4 minus 1 times 4, 4 minus 4 we get 0, minus 2 minus 4 we get minus 6, 6 plus minus minus it become plus, 4 3 are 12, 6 plus 12 we get 18, and 8 plus 4 we get 12. Then third row is multiplied by 1 by 3. 15 into 1 by 3 we get 5. Minus 3 into 1 by 3 we get minus 1. 9 into 1 by 3 we get 3. And 1 by 3 into 21 we get 7. And then using that one, we convert this 5 to 0 by applying R3 minus 5 times R1, we get first row no change, 1 1 minus 3 minus 1. Second row no change, 0 minus 6 18 and 12. Changes in third, R3 minus 5 R1 minus 1 and minus 5 we get minus 6. Then 3 minus minus plus 5 to the 15. 3 plus 15 we get 18, and 7 plus 5 we get 12. Second diagonal element is minus 6, non-zero element. We can keep that as it is, and using that minus 6 we can convert this element to 0. The required transformation is R3 minus R2. We get first row no change, 1 1 minus 3 minus 1. Second row also no change, 0 minus 6 18 and 12. Third row changes are by this transformation, R3 minus R2, 0 minus 0 we get 0, minus 6 minus of minus 6, minus 6 plus 6 we get 0, 18 minus 18 we get 0, and 12 minus 12 we get 0, 0 minus 0 we get 0, minus 6 plus 6 we get 0, 18 minus 18 we get 0, 12 minus 12 we get 0. And in the process, the third diagonal element becomes 0 and no element available below it, so that by interchange of rows we can make it non-zero. Therefore, we stop here. If we observe here, all these principal diagonal elements are non-zero except that last one. One, minus 6 and 0, and lower diagonal elements are 0. Means whatever this form is we have, it is called as canonical form. This is called as the canonical form. Once again, I will explain what is by canonical form. In canonical form, the principal diagonal element must be non-zero. First one is 1, non-zero. Second, minus 6, non-zero. Third, 0, but it becomes 0 in the process. And it is not possible to make it non-zero as no row is available below it. And lower diagonal elements all are 0. Therefore, this is the canonical form. And after getting canonical form, we find rank of A. This one is the A matrix. Number of non-zero rows. First row is non-zero row. Second is also non-zero row. Third row is a 0 row, as all are 0 elements. And therefore, we write down the rank of that matrix as 2. Then we find the rank of complete matrix, means augmented matrix. Complete matrix, this one. First row is non-zero. Second is also non-zero. Third row completely 0. And therefore, rank is again 2. And these two ranks are equal. And therefore, whenever the ranks are equal, then that system is said to be consistent. Here, the given system is consistent. Consistent means solution exists. Either it may be a unique solution or infinite number of solutions. And to decide it as per the conditions, here ranks are equal. But it is less than, ranks are equal and equal to 2, but it is not equal to number of unknowns. It is less than number of unknowns. System has infinite number of solution. System has infinite number of solution. To obtain that infinite number of solution, new system of equation, we have to convert matrix form to equation form. Therefore, from first row we get the equation as x plus y minus 3z is equals to minus 1. We call this equation 1. And second equation is minus 6y plus 18z is equals to 12. Second equation. And therefore, here we have only two equations. Last equation is containing two unknowns, y and z. Therefore, let consider any one of them as k, as we require to find infinite number of solutions. Let here I will consider z as k, suppose non-zero scalar quantity. Put that value in equation 2. Therefore, from 2 we get the value of y. Therefore, it is minus 6y. We transfer to other side, it become plus 6y as 18z, but z is k, and minus 12. This, and therefore y is equals to, dividing by 6 we get 3k minus 2. Substituting these two values of x, z and y in equation 1, from 1 we get the value of x as minus 1 minus y. Y is 3k minus 2 and plus 3z if we transfer it to other side. Therefore, plus 3k. Simplifying it, we get minus 1 minus 3k plus 3k get cancelled. Minus and minus, it become plus 2. And therefore, 2 minus 1, we get that value as 1. Therefore, the solution is x is equals to 1, y is equals to 3k minus 2, and z is equals to k. This is the infinite. Infinite in the sense we can take infinite values for k. K equal to 1, k equal to 2, k equal to 3, like this. Therefore, to cross check it, we consider one value for k as 1, suppose. For k equal to 1, we get x is equals to 1, y is equals to 3 minus 2 as 1, and z as k, k is 1, and therefore out of infinite, this is one of the solution. X is equal to 1, y equal to 1, and z is equals to 1. And for these values, we cross check whether that equations are satisfied or not. Therefore, the first equation is, I will write down that equation once again, 4x minus 2y plus 6z is equals to 8. Therefore, 4 into 1 minus 2 into 1 plus 6 into z, z is 1, and equals to 8. 4 plus 6, 10. 10 minus 2, we get 8. 8 is equals to 8. First equation is satisfied. Then we go for the second equation. What is the second equation? X plus y minus 3z is equals to minus 1. Substituting the values, x is 1, y is 1, and z minus 3 into 1 is equals to minus 1. 1 plus 1 we get 2, minus 3. 2 minus 3 is minus 1, left hand side is minus 1, and right hand side is also minus 1, means equation is satisfied. Then we go for the third equation. Third equation is 15x minus 3y plus 9z is equals to 21. Substituting values, 15 into 1 we get 15, 3 into 1 we get 3 minus 3, and 9 into 1 we get 9 is equals to 21. 15 plus 9, 24. 24 minus 3 we get 21 is equals to 21. Equation is satisfied. 21 is equals to 21. third equation is also satisfied. All equations are satisfied. Whatever the solution obtained is a correct one. In my next video, I will discuss a homogeneous type of linear simultaneous equation, how to solve it by matrix method. Please like my video, share it, as well as subscribe to my channel. And to receive the notification for my such type of new videos, please press the bell icon. Thank you. Thanks for watching.